Alright guys, here we go. Pre-calculus formative assessment 1.2. So use the graph of f to find the domain and range of the function. Use set builder notation. So set builder means we have those squiggly S brackets. So for my domain, my x values start here and go to infinity. So that's negative 1, 2, 3, 4, 5. So the set of all x's such that x is greater than negative 5. Because it's an open circle, I don't put the equal sign under here. And x is an element of all real numbers. So anytime you get a continuous function, so you can draw it without picking up your pen, it's not a whole bunch of dots, it's going to be all real numbers. Oh, sorry, this is pre-calculus, sorry. Okay, so for range, sorry about that. We do it differently in Algebra 2, so I have to get my head in the right mind space when I make these videos. All right, for range, we are talking about y values. This is going to be a set of all y's such that my lowest y value includes negative 3. So y has to be greater than or equal to negative 3. This thing's going to go on and out to infinity. And then again, y has to be an element of all real numbers. So that's the same thing for the other version. All right, so for version 1, define the 0. The 0 of the function is also an x-intercept. When we are crossing the x-axis, my y value is equal to 0. So I'm going to set my y value equal to 0 and then solve for x. So to solve this guy for x, I'm going to add 2 to both sides. 2 is equal to 3x, divide by 3. X is equal to 2/3. A lot of people got that far and left it. This here is the equation for a vertical line where x equals 2/3. I don't want that. I want the point, not a, your zeros and your y-intercept should be a point, not a line. So you want to give me the point, x is 2/3, y is 0. All right, looking at the 0 on the other version, if you have the other version, it would be 0 again is equal to 5x minus 3. Adding 3 to both sides, 3 is equal to 5x. X is equal to 3/5. Again, that's a line. I don't want to see that. What I want to see is 3/5 for x, 0 for y. That's a point. Your 0 should be a point. Your y-intercept should be a point. All right, for number 3, to decide whether something's even, odd, or neither, we're going to plug in f of x. Sorry, we're going to plug in f of negative x. When I put a negative x in there, I've got negative x cubed, and then minus 4 times negative x. All right, so negative times negative is negative. Remember, an odd power is going to be negative, so this would be negative x cubed. And then negative times negative makes this positive 4x. So we ask ourselves, is this f of negative x equal to my f of x? And no, it's not. So we know it's not even. My second question, is it equal to negative f of x? So if I put a negative in front of this guy, I'd have to change the signs of each of these guys. So from positive to negative, from negative to positive. And yeah, that's what I got, negative x cubed plus 4x. So since this guy is equal to negative f of x, this is an odd function. And because it's an odd function, we are symmetrical about the origin. So remember, even functions are symmetrical about the y-axis, odd functions are symmetrical about the origin.
I don't think they get it.
All right, for the other version of it, I'm gonna again put in negative x. So I've got negative x cubed, and then minus 4 times negative x. Oh, is it the same? Oh, these are the same for both of them. So again, it's an odd function. All right, moving on to number 4. To find the y-intercept, that's when we cross the y-axis. For this one, x is equal to 0. So I've got h of 0 is equal to 0 cubed plus 6 divided by 2. And so 6 divided by 2 would be 3. So this is what x is 0, y is 3. If you had the other version, it is the same. Oh, you guys lucked out. All right. Last thing we have is the table. So we need to decide, is this even, odd, or neither? So if I've got this as my x and this is my y, if I put in a negative x, here's my negative x, does it give me negative y? No, it gives me the same thing. So this is the same thing as if I put in negative x, it gives me the same y value as f of x. So putting in a negative x value gives me the same y. So this is an even function. And the tables were the same, so that was the same for both of them. So those are the solutions to formative assessment 1.2. Come to tutorials if you have questions.